categorical. So data are frequencies. This is, I think, this is known to all of you. Chi-square put there, but this is based on null hypothesis. A pharmaceutical company claimed that their new product can cure 80% of patients. Data 56 out of 80 with disease got cured. So that is 70%. Now, chi-square is, this is the observed, this is the expected, by expected. Observed minus expected square by expected. Now, why this is so? This is just a null hypothesis. What null hypothesis says? That everything, there will be no difference between different sets of data. So if we apply this, we will get this type of data. This is not required. In case of chi-square test, exact test, one test is known as Fisher's exact test. Exact test is recommended when both variables are dichotomous, qualitative, and when the overall total of the table, means sample size, is less than 30, or when any one expected cell value is less than 5. If total sample size is less than 30, or any one expected cell value in chi-square test is less than 5, we have to do Fisher's exact test. If the sample size is more than 30, but expected cell value is less than 5, then we have to go for Yates correction. So one is Fisher's exact, another is Yates correction. Now scattered diagram, it has already been told. As the age increases, BP also increases. So in case of correlation, we see what is the direction, what is the extent of relationship. What is the difference between association and correlation? This is very important. Customarily, association and correlation are roughly means the same, but in statistical sense, association is the term used for assessing relationship between two categorical variables. But correlation is the term used for assessing relationship between continuous variables. Like age, continuous variable, blood pressure, continuous variable. There we see correlation. Correlation is depicted by R, independent relationship between two variables. It may range from -1 to +1. Close relationship means 1. It may be minus, it may be plus. -1 means strict negative correlation, +1 means rigid positive correlation. No relationship, there R will be 0. In case of normal distribution, Pearson's R test. In case of non-normals, Pearson's R test. So this is R equals to 1, positive correlation. R equals to 1. Here R equals to 1, but it is negative correlation. R equals to -1. It is somewhat positive, so R equals to 0.8. No correlation is there, so R equals to 0. A note of caution. Correlation coefficient is purely a measure of degree of association and does not provide any evidence of cause-effect relationship. It is valid only in the range of value studied. মানে যতটা ভ্যালু আমি দেখছি আমি কিন্তু তার উপরই কমেন্ট করব, তার বাইরে করব না। এক্সাম্পল হচ্ছে এজ এন্ড গ্রিপ স্ট্রেংথ। As the age increases up to a certain level, grip strength increase, then it is fixed, plateau stage, and then it closed down. So by seeing only this, if I comment as the age increases, grip strength is always increased. Got my point? We cannot comment. So I have to, it is valid only in the range of value studied. Another is R equals to 0 does not mean necessarily that there is no relationship between two characteristics under study. The relationship could be curvilinear. R depicts only linear relationship. If r equals to 0, we can say that there is no linear relationship between two continuous variables. But the relation may be curvilinear. So scatter plot is a must. Spurious correlation. The production of steel in UK and the population in India over last 25 years may be highly correlated. But that is a spurious correlation. Be aware of outliers. If there is outlier, r equals to 0.4. If we cut it, r becomes 0.7. Sensitive to number. This is important. Here correlation is 0.6 and here correlation is 0.3. Now which one is better? Which one is better? Which shows which one is more specific? Obviously 0.6. But if you see the confidence interval minus 0.6 to 0.7. It includes 0 also. So the correlation may be negative, there may be no correlation, and correlation may be positive. So there is no specific conclusion from this correlation. Here correlation is only 0.3, but the confidence interval is 0.2 to 0.4. Means correlation is always positive. So a specific conclusion is there. So if we increase the number, it becomes significant specific conclusion. Because number of study subjects here 223, number of study subjects only 34. So from this slide, we can understand the importance of confidence interval. This is just a minute. Excessive use of hypothesis testing at the expense of other ways of assessing result has reached such a degree that level of significance are often quoted alone in the main text and abstracts of the papers, with no mention of actual concentration, proportions or other differences. Confidence interval now is the most important part. P-value, actually this doesn't matter. We have to see the confidence interval. Statements such as P less than 0.05, P more than, P equals to convey little information about the study findings and encourage oversimplistic interpretation. Even exact P value convey no information about the size of a difference or strength of an association. That's why confidence interval is very much important. Now the last one, regression. Only 2 minutes. Regression means method of describing. 5 minutes. Method of describing the relationship between two variables to predict the value of one variable given the other, like patient's age and systolic BP. So we can perform a regression of BP on age to deliver a straight line that gives an estimated value of BP for any given age. So the general equation for a linear regression line is y equals to a plus bx. A is an intercept, B is regression coefficient. Clear? Assumption, outcome is normally distributed, independent observations, relationship between variables is linear. It must be linear. So we can write in that way systolic BP equals to A is constant, 100.34 plus what is B? B means regression coefficient, 1.08 into age. Okay, but the problem is if age equals to 0, what will be the systolic BP? It is 100.34. Is it possible? No. This is multiple linear regression, same thing, but the variables are more than one, height, weight, etc. And we can also use logistic regression, where the outcome is dichotomous. Means, আমরা ওখানে কি করছিলাম সিস্টোলিক হাইপারটেনশন মানে বিপি লেভেল দেখছিলাম এখানে কি is the patient hypertensive, yes or no. If the outcome variable is dichotomous, then we can use logistic regression. Okay. So logic P equals to A plus BX plus CY plus A or something like that. Okay. So thank you.
Thank you, Dr. Banerjee, for a very nice presentation. The second of our today's master class. This is the conclusion of program. May I request Dr. Malay Vera to come to announce our next program.
Next program is will be at Medical College, Kolkata. There will be 2 days workshop. First day will be a laparoscopy and robotic surgery workshop. The eminent surgeons will come from outside, even internationally famous surgeons. And second day will be on stone management, RALS, PCNL, beneficial, etc. That is also from nationally reputed surgeons. Not for that. Today it was really nice thing, maybe new one, because most of the students were not exposed to the statistics particularly, and probably it has become very much hard to us. In fact, we were in our time when we did our thesis, there was not so much improved. But nowadays, as we are improving, as our statistics also improving, our methods of research is also improving, we have to progress with that. So very thanks to our eminent teachers. They have come with their so much preparation as well as giving so much time to us. Very thanks. Also thank to this Alembic for their support. Thanks to the audience staying so much time from. We are behind the schedule, not because of there were many hurdles with that. So thank you, and we are concluding our today's session. Thank you very much.